this one, concurrency control techniques. Now the second technique is timestamp ordering technique. So what happened here is for each and every transaction that means when the transaction submitted to the system, what will happen is a timestamp will be given to it. A unique timestamp will be given to it. Okay, so it is going to be the identifier which will uniquely identify a transaction which is already submitted to the system. Means when it is going to execute, it needs to submit to the operating system. No, so that's why when a transaction submit itself to the system, Dbms is going to give a timestamp. The Dbms is going to give a unique identifier, and it is known as timestamp, which will be identifying the transactions. Okay, each and every transactions will have a unique identifier to identify itself. Okay, before execution. So even here, the definition for timestamp is given. And for representation, timestamp of transaction T will be represented as TST. Okay, so it means the timestamp for the transaction T. So one thing here is normally a timestamp that is given to a transaction, and it's going to be the time at which means at what that particular time in which the transaction is submitted. Okay, so normally this particular assignment is done. Okay, so that means all the transaction will have smaller values of timestamp, and younger transaction will have and this one larger values of timestamp. Okay. Now let us read these things. The first one is in order to know how timestamp ordering technique works, we need to know some of the few representations. The first one is TST that we already see. That it will represent the timestamp for a transaction T. Now writ timestamp. What is this writ timestamp? So writ timestamp for a variable, for an item or for a data X that is present in our database. So what it is going to be? With TSX, it will be represented like this. X is the item or data. Okay, X is going to be a data. So with timestamp of a data is going to be what? Is the largest timestamp among all the timestamps of transaction that have successfully read item X. Okay, so X, the data X that is there in our database is going to be read by many transactions, isn't it? So let us assume that it is read by many transactions. So from those transactions, we are going to select the youngest transaction. Okay, or you can say the transaction which is having the the largest timestamp value. Okay, so that timestamp value is going to be the read timestamp of that item, of that particular item X, of that particular data X. Okay, so that is read TSX is going to be equal to TST, where T is the youngest transaction that has read X successfully. Okay, so just remember this, read TSX equal to TST, where T is the youngest transaction, or you can say where T is the transaction which is having the largest value of timestamp. Okay, youngest transaction that has read X successfully. Okay, same thing for write timestamp also. Write timestamp, write TSX is the largest of all the timestamps of transactions that have successfully written X. Okay, so it is going to be the timestamp for the youngest transaction that has written X successfully. So if we know these things, let us see the rules for timestamp ordering technique. So when we are going to be able to, means when the transaction will be able to perform a particular operation. So this rules will tell you, at what time a write operation or a read operation will be able to take place. Okay, the first one is for write item X. Transaction T issues a write item X operation. when a transaction T issues a write item X operation, what will happen? These two things will be checked. Okay. So we have to, means the transaction is going to follow these two rules if it is going to write the particular item X. If read TSX is greater than TST, okay, if read TSX is greater than TST, that means a younger transaction than this T, younger transaction already read the value X before T issues the write item X. Okay, this particular statement means what? Means a younger transaction already read the value X before T issues write item X operation. Okay, if this condition satisfied, or a younger transaction already write the value X before T issues the write item X. If any of these two conditions satisfied, then we cannot, means the transaction cannot execute this write item X. Okay, because a younger transaction that submitted later after this T already has done some operation on it, whether it is a read or a write. Because write-read is going to be a this one. Write-read is going to be a conflict operation, isn't it? Write-write is also a conflict operation. Okay, so that is why then abort T needs to be abort. T needs to be abort. Okay, then abort and roll back T and reject the operation. Okay, the operation this particular write item X will not be able to perform. This transaction is resubmitted to the system as a new transaction with a new timestamp. Okay, it will be abort and roll back, and after some time it will be resubmitted later on with a new timestamp. Okay, so why this is happening is that already a younger transaction which is submitted later already read or write the particular item X. So that means if it already happened, then we can't execute this write item. Okay, that is why. Otherwise, if this two particular condition is not satisfied, then we can execute, means transaction can execute the write item X. Execute the write item X operation of T and set. So this needs to be converted, isn't it? Because already a write item X is done, means an operation is done, means already it is written by a transaction T. So the timestamp for T needs to be allocated, means needs to be rewritten to the write timestamp X, isn't it? So it will be set to TST. Okay, because why? Because T is going to be the youngest transaction. If this two is not satisfied, then T is going to be the youngest transaction who performed this write item X. That is why the timestamp of T will be assigned to the write TST, write timestamp of X. Okay, any doubts in this particular rule number 1? Okay, then let us see rule number 2. This is for issuing read item X. Read item X. So as it is read, it will be conflict if there is a write, isn't it? So that is why we need to check only for write. Other things means if it is read, then it doesn't matter. Means it will not create any. It will not result into a problem. Okay. So what will happen? Let us see. If so, that is why only a write means only a write operation for that is done by a younger transaction is this one checked here. If write TSX is greater than TST, that means a younger transaction already written the item X. Then abort and roll back. Then abort and roll back T and reject the operation. Same thing again after aborting and roll back, it needs to be resubmit later on, okay, with a new timestamp. The second thing, if write TSX is less than or equal to TST, Okay, means if it is um, means if write is done by a particular transaction which is older than this t. Okay, older or same thing. If the same transaction has done a write item to this x before, okay, then execute the read item x operation of t and set with tsf to the larger of tst or the current with tsx. Okay, why we are not checking for the with? Because with are not conflict operations, isn't it? So with can be done. That is why you can see here with tsx needs to be set to the larger of tst, either tst or the earlier value of this tsx. From this two, the larger value will be chosen, and then that value will be assigned to this particular with tsx after reading. Okay. So this is the rule for timestamp ordering technique. So whenever a transaction wants to execute any read or write operation, so it will be checked whether is there any conflicting operations that is already executed by a younger transaction or not. And after that, if it is not executed, then the operation will be executed. If it is not there, if that condition does not, if that condition satisfied, then it will abort and roll back. Okay. Any doubts? Okay, so here you can see, you can just read this out. Hence, whenever the timestamp ordering detects two conflicting operations that occurs in incorrect order, okay, two conflicting operations that occur in incorrect order. Just remember this one. It rejects the latter of the two operations by aborting the transaction that issued it. Okay, so that because of this, it is going to guarantee serializable. Okay, because if two conflicting operations are issued in an incorrect order, then the latter one which is issuing the particular operation needs to be aborted, isn't it? So if it aborts, then what will happen? It guarantees serializable. Okay. The schedules produced are hence guaranteed to be conflict serializable. So I told you that whatever technique that we have for concurrency control, there needs to guarantee the serializable, means they need to guarantee, means they need to produce a schedule which is serializable, isn't it? So here means I have given how the timestamp ordering is going to lead you to a particular serializable schedule. So like that, the same thing, two-phase blocking technique will also will also give you a serializable schedule. Okay, so just see those things, means how it is going to produce a serializable schedule by the two-phase blocking technique, and also by timestamp ordering technique. You see it by using some few example transactions. Okay, as an example. Okay, so I will give it as an assignment. You just search it from the web also. You will find many transactions, and just write few means you have to explain how two-phase locking technique guarantees serializable schedule, and also how timestamp ordering technique guarantees serializable schedule. Okay, so I'll give it as an assignment. This is going to be your last assignment. And in the next week, like I say in the previous class, we'll have another this one unit test. Okay, so we'll have 3 unit tests. So this is going to be a second unit test, and after completing your syllabus, I will take another this one unit test that will cover the whole syllabus. The last unit test will cover the whole syllabus. Okay. Only some few topics are left. So we will need like 3 to 4 classes to complete it. Any doubts? Anything you want to ask? I'll give class notes for. I don't think I need to give class notes. I have already provided you this one, isn't it? This presentation. You have this
Yes, ma'am.
presentation.
Yes, ma'am.
Okay, then just follow the presentation, and if you want to know details, then in details, then you can check any of the book that I have given you as a reference, and or you can also see from the web also. If you have any means, if you are not able to find the particular means, you can, if you are not able to find a detailed information about a particular topic, then you can ask me also. I'll provide it. Let me take your attendance. Visit enrollment number 1,
Yes, ma'am. Present, ma'am.
2,
Present, ma'am.
3, Atul Sharma absent, 4,
For present, ma'am.
5,